Integral of 3 square root of x cubed with respect to x. Before we start integrating, we need to rewrite this square root of x cubed as a power of x with fractional exponent. So that will look like 3x, and now what do we do here? 3 is the index or the exponent. 2 is the index of the square root, always 2. So what happens is we do 3 over 2. So it's always the inside over the outside with respect to x. Now we are ready to integrate. We have to add 1 to that power, and on the side here, let's do that same calculation as we've done before. 3 halves plus 1. In this case, again, it's convenient to look at 1 as 2 over 2, which is the same as 1. But now denominators are matching. We can keep the 2 on the bottom and simply add the top numbers, so giving us 5 halves. So let's rewrite this here. Integral of 3x to the 3 halves. When we add 1 to the power, we keep the 3, the coefficient, and we have x to the 5 halves, and still divide by 5 halves plus the constant. That's the case when we have like fraction over fraction, so we have to multiply by the reciprocal of that fraction on the bottom. So we have 3, the coefficient, multiplied by 2 over 5 instead of 5 over 2, x to the power of 5 over 2. And to simplify further, we just multiply 3 as a whole number is the same as 3 over 1. So 3 2s is 6, 1 5 is 5, x to the power of 5 over 2 plus c. So as soon as we see a root, we remove the root and write it as a fractional exponent. And another example would be integral of 6 over the cubic root of x minus 8 multiplied by the square root of x cubed with respect to x. So as soon as we see roots, we have to rewrite them as powers of x with fractional exponents. So we're not integrating yet, we're just doing some manipulation here, rewriting the expression. So looking at this cubic root, x is to the power of 1. So we rewrite it as 6 over x to the power of 1 over 3. Always the one inside over the one outside. Minus 8. Same as with this other one, it's square root. So we rewrite that as x to the power of 3 over 2. With respect to x, that's what we want to integrate. Not ready to integrate yet because this power of x here must be sitting at the top, not on the bottom. So we rewrite the integral of 6 x to the 1/3, but because we want it on the top, change the line, change the sign, we needed to change the exponent sign. So 6x to the negative 1/3. The other one is already sitting on the top, we just copy. Now we are ready to integrate. So this needs 1 added to each exponent. We'll do one at a time. So we have 6x. Let's add that together. Negative 1/3 plus 1. This time it's convenient that the bottom number is 3. So 1 can be rewritten as 3 over 3. And then we keep that 3 on the bottom and operate the tops. Negative 1 plus 3 will give us 2. So 2/3. Negative 1/3 plus 1 is the same as positive 2/3, which is the new exponent here. Minus 8, copy the coefficient, and then add 1 again. So 3 halves plus 1. This time it's convenient that 1 is rewritten again as 2 over 2, so the bottoms are matching. So final answer will be 2 on the bottom, 3 plus 2, 5 on the top. So x 5 over 2 plus the constant. There is one thing missing in each of these terms that hasn't been done yet. We should once we have added the exponents, we have to also divide the term by that sum. And same with the next one, 3 halves plus 1, 5 halves. So divide the term by 5 halves. Doesn't look good for a final answer, so we have to multiply the term by the reciprocal of what's on the bottom. So in this first one will be 6 times 3 halves. So 6 times 3 halves, x to the power of 2/3 minus, same with the other one, we'll have to multiply by the reciprocal of what's on the bottom, minus 8 multiplied by 2/5, x to the 5 halves, plus the constant. So some simplifying is needed here. So we can say 6 divided by 2 there is 3. So we have 3 3s are 9. We'll put the answer right here on the bottom. So 3 3s are 9. We have 9x to the 2/3 minus 8 times 2/5. We cannot simplify, so we'll just multiply across. 8 2s are 16. 1 5 is 5. And then x to the power of 5/2 plus the constant. So important things here. Roots have to be rewritten as powers of x with fractional exponent. If the root is sitting on the bottom, we will then first change it to a power with fractional exponent and then move it to the top, changing the sign of that exponent.